Hello, welcome to this lesson where we want to look at the whole paper. The whole paper. And which paper are we talking about? The Maths Paper 1 2020 December exams. ECZ exams. We want to look at the whole paper from question 1 up to question 23. As you may know that this exam has 23 questions. So we are looking at those questions in full within this lesson. Okay? In the previous lesson, I tried to present a few questions from this paper, but in today's lesson, I want to present everything from question 1 up to question 23. So I'll try to do these first 3 on the board, then the last 20, I'll demonstrate how you must answer them right on the paper. Okay? So let us look at the first one. How do we simplify this question? So we need to get rid of the brackets. We need to get rid of the brackets, that is the first thing. So we need to expand. 2 multiplied by x, we're going to get 2x. 2 multiplied by 3, we're going to get 6. And then here, we also do the same thing, okay? So we're going to have 3x multiplied by x. This gives us minus 3x squared, okay? Then look at this. We have a minus here as well as a minus. So this is going to give us a plus. What do we get? 3x multiplied by 2, we're getting 6x, okay? So when you look at this and this one, they're like terms. So meaning we want to say 2x plus 6x plus 6 minus 3x squared. We are putting the like terms together, which are these. So these are going to give us 8x plus 6 minus 3 squared. This is what is going to be our answer to the first question. This is what is going to be our answer to the first question. Then the second question. The second question here, we are looking at the cube root of 27. What is the cube root of 27? The number that you ought to multiply by itself 3 times, then it should give you 27. What is that number? It is 3. Then we square because we have a 2 outside. When we expand this is 3 multiplied by 3 as opposed to 3 multiplied by 2. So this is going to give us 9. Okay? This is going to give us 9. Then we look at the third question. So what are we supposed to do here? When you look at this question here, we need to factorize. So first of all, when you look at it, we have 4, which is common. 4 is common here. So we can say 4 open brackets, here you have another 4x squared minus 25. Then after we have done this step, check what is in the brackets. We have done 4 methods of factorization in this syllabus. So we should move from one method to the other. Here we use the common factor method, but when you look at what we have in the brackets, we have one method that can apply, which is which is a difference of 2 squares. So in a difference of 2 squares, it will mean that we need now to have 4. We change this one, okay? What this is going to be 2 the x squared minus 5 squared, okay? This one is applying on both, okay? So finally, we can come up with our answer as 4 2x plus 5, close, open brackets, 2x minus 5, close. This is the answer to the third question. But just like I indicated at the beginning, that the rest of the remaining questions, we're going to do them right in the paper so that you see how you're supposed to answer it. Okay? We are teaching you as well as helping you to see how you must handle these questions in the exam. So let's go to the paper now and see what we're talking about. Alright? That's what we want to do. Okay, so we come to question 4. Just like I indicated that for the last 20 questions, we'll do them right on the paper. So here is the question. The points A and B are -5, 15 and 3W, W respectively. Given that the midpoint of the straight line joining A and B is 5, 10. Find the value of what? Okay, so I'm sure we should know that to find the midpoint, we always use the formula x2 y1 x1 plus y1 over 2. So this is what gives us, these are the coordinates that give us the midpoint. So we know that when we deal with this one, it will give us the x coordinate for the midpoint, which in this case is a 5. Okay? So now we are going to, we can either use, so to find the value of y, to find the value of w here, we can either use this one, because we also have w, or we can use this coordinate. Okay, so either, whichever you use. So here we can use the first one. What is our x2? Our x2 is 3w plus, what is our x1? We come to the x1 is minus 15, isn't it? X1 is minus 15, which is minus 15 divided by 2. This must give us the x coordinate, which is 5. So when you work out this is going to give us 3w minus 5 is equals to 10. Okay, it's going to give us this. Then now we say 3w is equals to 15. Where is this 15 coming from? This 5 came the other side, and the additive inverse is what? Is positive. So you add the 5 the other side. Then the value of w, what do? We divide both sides by 3. So w is equals to what? W is equals to 5. W is equals to 5. So we come and write our answer here, 5. All right, that's what you're supposed to do. Then we go to question 5. So question 5, we are told that the vector RS is given by 4 and 3. Given that the coordinates for R is, given that R is a point -2, 1, find the coordinates of the point S. Okay, so OR, which is a position vector, is 2, -2, 1. Okay, then here in form of a vector, this is like RO plus OS is equals to, what are we supposed to get? -4 and 3. That's what we're supposed to get here. Okay, now we want the coordinates of S. We want the coordinates of what? Of S. So now what are we supposed to do? So if this is our OR, then RO is going to be the opposite of this one, which is what? 2 and -1. Okay, it will be the opposite of this one. Then plus OS, which is equals to -4 and 3. Then we want to find OS. Take note. So OS is going to be equals to -4, 3, and this one will come the other side here. This one is going to come the other side here. We have 2 minus 1. So when you simplify this one, the first one is going to be -4 minus 2. The second one is going to be 3 minus 1. Okay, then what do we get here? The first one is going to give us -6, and the second one will give us 4. Okay, so now the coordinates that we want, we're going to say the coordinates of S are 6 and 4. These are the coordinates of S. These are the coordinates of S. Are we together? These are the coordinates of S. So we can go to the next question. Go to the next question here. What's the next question? Look at this question here. On the Venn diagram, in the space below, shade the region A, complement, intersection, open brackets, B, union, C, close brackets. Okay? So now, what are we talking about here? What are we supposed to do? Okay? What are we supposed to do? What we're supposed to do here is that, in this case, what we're being asked to do here is, we need to make sure that A complement, meaning the region that is outside complement. Okay? So if we can start with B union C. B union C, we are looking at the entire part that is in B and C. We shade everything that is in B and C. Okay? Then when it comes to A complement, meaning this part that is in A must be removed. So the part that we are talking about shading here is this one. Okay? This is the region that we are talking about here. That's what you must shade. That is what you are supposed to shade. That is what you are supposed to shade there. That's our answer. So let's go to the seventh question. So given that we have those two matrices there, M and N. So the first one, we need to find the transpose. MT is the transpose of M. So we need to transpose that. So what are we supposed to do? So, you know, how do we transpose? The rows will become columns. So the first one there is going to be, you transpose that matrix where the rows will become columns. So the answer is -3, 4, 0, -1, 2, -2. Okay? So this is what we're going to get as our answer. This is what we're going to get as our answer. Okay? Then we proceed. This one, we need to multiply these two matrices. We need to multiply these two matrices, M by N. Okay? M by N. So our M is -3, -1, 4, 2, 0, negative. Then by N. Okay? So -2 and 1. So what is the order of this matrix, if you like? We have 1, 2, 3 rows by 2 columns. Then the second one, we have 1, 2 rows by 1 column. So our answer, okay, our answer, the order of our final answer, it is going to be a 3 by 1. That is just a guide. That is just a guide. Okay? So we need to make sure that we do that. So let's do that. So this is going to be 3 by -3 by -2. What do we get? -3 by -2. What do we get? We are going to get 6 plus -1 multiplied by this one. We're getting -1. Okay? Then we come to the second one. What are we getting? Then this other one, it will be 4 multiplied by -2. We are getting -8. Plus 2 multiplied by 1. We are getting 2. Are we together? Then we do the last one. 0 multiplied by -2. It's 0. Plus -2 multiplied by 1. It's negative. Are we there? So this has to be simplified now. How do we simplify it? This is going to be 6 minus 1. 6 minus 1, we get 5. -8 plus 2, we get -6. 0 plus -2, we get -2. Okay, so this is what is going to be our answer. So our answer here now is going to be it's going to be 5, -6, -2. That is what is going to be our answer. So we're going to the 8th question. Okay, so on the 8th question here, for the sequence for the sequence 7, 11, 15, 19. Find the ninth term. Find the ninth term. I'm sure you remember here that we have our formula. The nth term. The first term plus n minus 1, then by the common difference. Okay? So we need to find the common difference here, which is the second term, which is 11, minus the first term, which is 7. What are we getting here? Okay? What are we getting? We're going to get 4. Okay? That is our D, which is the common difference. So A is the first term, which is 7, plus n is 9 minus 1 multiplied by 4. 7 plus, we have 8 here, multiplied by 4. Are we together? That's what we are getting. So you know that the rules here are that you need to make sure that before you add, you multiply. This is going to give us 32. When you add this, you get 39. So we can write 39 here. 39 is our answer. Okay, 39 here. Then the second one is the sum of the first 16 terms. The sum of the first 16 terms. So I'm sure you know that the sum is given by the formula. Sum of the nth term is given by the formula n over 2 or 2a plus n minus 1 d. Okay. So this is the formula. So we want the sum of the first 16 terms. So where there is n there, we're going to put 16 over 2, open brackets, 2 multiplied by 7, 2 multiplied by 7, then plus, what do we want here? 16, isn't it? We're talking about 16. So it's 15, I mean it's 16, which is the nth term. 16 minus 1, it will give us 15. 15 multiplied by 4. All right. So this gives us 8 here. This one gives us 14. This one gives us what? 60. Okay. So what are we going to get here? This gives us 8, and then this gives us, I think, 70. Okay, it's giving us 70. So you multiply this one. We multiply this one. What are we getting now? That's what we're supposed to do. 4 multiplied by 8, we're getting 32. So we write our 2. We've carried what? All right. Then we have our 2. We have our 3, I mean. Then, so 32. Then 8 multiplied by 7, we're getting 56. So 56 plus the 3, we're going to get 59. So this is our answer here. So we write 592. That is our answer here. Okay. So we go to the ninth question. We go to the ninth question. The probability of Masamushi failing an exam is 3 over 10. What is the probability that she will pass the exam? So the probability of Masamushi, the probability of this Masamushi failing the exam, okay, plus the probability of passing the exam must give us 1. So if we are given the probability of failing and we want to find the probability of passing, we're supposed to say the probability of passing, okay, probability of passing is equals to what? 1 minus 3 over 10. And this is going to give us, what's the probability of passing? When you subtract this one, it's going to give us 7 over 10. All right. So this gives us 7 over 10 here. Then we go to the second question. A plan, okay? A plan of a play boat is drawn to a scale 1 to 20 centimeters. If the actual area of the base of the boat is 0.64 meter square. Calculate its area on the map in centimeter squared. Okay, so here there's one thing that we are supposed to understand. There's one thing that we are supposed to understand, and it's very important. So the first thing that we're going to do is that we must say 1 meter is equals to 100 centimeters. Then when we square this meter here, we also need to square this side. So what are we going to get? We're going to get, okay, 10,000, isn't it? We're going to get 10,000. That is that, centimeter squared. So 1 meter is equals to this one. So you must understand that. You must understand that. All right? So now we can come and do it. We have 1 over 20, which is the scale. That is the scale on the map, 1 over 20. Then this side, okay? Remember, this 1 centimeter on the map represents 20 centimeters on the ground. So this is on the map, this is on the ground. Okay? So here we want on the map. On the map, this is what is missing. On the ground, it is given as what? It's given as 0.4 in. So we need to convert this one. You need to convert this one into what? You need to convert this one into centimeter squared. You need to convert this one into centimeter squared. So we're going to have 0.64 multiplied by 10,000 centimeters. So that's squared. Okay? Now, if this part is squared here, don't forget we need to square also this part. It must be squared. This part must be squared also. So when we square this part, we're going to have 1 over 400 is equals to x over, when you multiply this one, you count. We have 2 decimal places here. So we are going to have 6, 4. You get 2 zeros from this one here, isn't it? You get 2 zeros here. That's what you're going to get. At this point, you cross multiply. When you cross multiply, you're going to have 400x is equals to 6,400. Okay? So you divide both sides by 400. You're going to get divided by 400. So what do you get here? What do we get? You are going to get, you cancel the zeros, 4 into 6, what do we get? We're getting 1. Then what will be the remainder? The remainder will be 4. The remainder will be 2. 4 into 24, it is 6. So we are going to have what? 16. Remember, centimeter square. That's what we're going to have. So we go to the next question here. So we come to question 10. Okay. Come to question 10. So question 10, saying given that the universal set has these elements and A has these elements, B has these elements, list A intersection B complement. So what is this set? This set is telling us that what are those elements that are in A but they are not in B. That is what it's saying. Those elements that are in A but they are not in B. If you want, we can sketch something here. Okay. This is our A and this is our B. So the elements that we want are those ones that are just here. They are just here but they are not in B. So what is common here? What is found in both sets? What is found in both sets? Okay? What is found in both sets here? Look at these 2 sets. We have 6, isn't it? That is the only thing. Then this side in B we have 3 and 18. Then in A, what do we have? In A we have 9 and 12. 9 and 12. So these are the elements here. A intersection B complements. Those elements that are in set A but they are not in B. In this case we only have what? 9 and 12. That is our set. Okay? 9 and 12. Those are the elements. So let's go to the second question. This question, you know that this is coming from index notation, a grade 10 topic. So where the index is unknown, we need to make sure that we have the common base. We have the common base. So we look at these 3 and 27. Which one should we write so that we rewrite so that we have the common base? Of course, it is 27. So this side we have 3x plus 3. This is equals to 27 or 3 to the power 3 over, okay. So what does this give us? This is giving us what is in the brackets here. 3 to the power 3 is the same as 27. So we go on and say 3x plus 3 is equals to, according to the power rule here, you have to multiply this one by that one. We're going to have 3 to the power 15. Then once the base are the same, we equate the indices. So we're going to have 3 plus, x plus 3 is equals to 15. And x is equals to 15 minus 3. Our x is equals to 12. So our x is equals to 12. That is our answer there. So we come to question 11. Question 11 reads, the diagram below shows two towns, A and B, on the equator. A is on latitude 35 degrees west, and B is on longitude, A is on longitude 35 degrees west, and B is on longitude 40 degrees east. Okay? That is what we have there. So the question is, find the time at A. Find the time at A. Find the time at A when it is 18 hours at B. When it is 18 hours at B. Okay? So what are we supposed to do? So we need to make sure now here that we get to find the difference in degrees here. We first get to find the difference in degrees, which will be, since these two places are on different sides of the Greenwich meridian. To find the difference in degrees, you need to add them. We've got west and east, so you need to add them. So when you add them, what do you get? You have 35 degrees plus 40 degrees. This is going to give us 75 degrees. So this 75 degrees, we need to divide it by 15 degrees, because we know that 1 hour is equal to 15 degrees, and this is going to give us 5 hours. And this 5 hours is the time difference between these two places. They have their time difference, okay? They are 5 hours apart in terms of time. Okay. So now what will determine what time it is at A is the side, the position where it is of B. If it is on the west side, as it is here, to find time as we go to the west, time reduces. In other words, we need to subtract 5 from 18. So when you subtract 5 from 18 hours, you're going to get 13. We're going to get 13 hours. That will be the time there. We're going to get 13 hours, right? We're going to get 13 hours. So we move on to question B. A plane flying from A to B takes 5 hours. Find its speed. Okay? Find its speed. A plane moving from A to this point. So we are saying speed, as you may know, speed is equal to distance over time. Now time has been given here as 5 hours. Then what is our distance? So we need to find the distance here. We need to find the distance. How do we find the distance? That is what is very important. So now you need to come to this point where we are going to find it. So to find the distance here, we are going to say the distance, which is AB, is equals to you know that it is theta 360 multiplied by 2 pi multiplied by r multiplied by cos x. Okay, so what is our theta? Theta is the difference in degrees, which we already got as 75 over 360 multiplied by 2 multiplied by 22 over 7 here. Okay, then multiplied by our we can use the, what is the radius? Okay, the radius is 3437, then multiplied by cos theta, meaning the latitude, the degree on the latitude where the two positions are. What do we get? We get 0. Okay, we get 0 here. So we work out this one now. When you work out this one, it's the question of us simplifying. This is going to be 75 here. Okay, so we can simplify this part here. For instance, if we say 2 here, it's 180, which is that 2 goes. 2 here, it's 90, then this will be 11. Okay, then 7 here, 7 into 34. What do we get? It goes into 28. How many times? 4 times. Then remainder 6 into 63. It's 9. Then here 1. Then cos 0 is equals to 1. Cos 0 is equals to 1. Cos 0 is equals to 1. So we calculate this part. So we need to multiply 75 by 11 by 491 over 491, then multiplied by cos 0 over 90. But then if we go by this method, we'll end up with a fraction, and we're going to have difficulties. So maybe since we're dealing with paper 1, we can abandon this one and use a more specific method, which is maybe AB is equals to theta multiplied by 60 multiplied by cos x. Okay, I think this will be, now this one works only in nautical miles. All right, so we need now, what is our theta? We got 75, that is what we got here, multiplied by 60 multiplied by cos 0. Now cos 0 is equals to 1. So it's like we're just multiplying these two. So let's multiply 60 multiplied by 75. What are we getting? 60 multiplied by 75. Let's multiply this one. It's like 7506. So we have 0 here, another 0. Okay, then this gives us what? 42 plus the 3, 45. Yes, so we have 4,500. So this is our distance now here, which is 4,500 here, 4,500. So then when you divide this one, what do you get? You get 900. Now this distance, we're dealing with nautical miles, so this will be 900 what? Knots. This will be 900 knots. That's what's supposed to be here, 900 knots. So let's go to question 12. Okay, so we are on question 12. We have these functions f and g. Now we want the inverse. How do we find the inverse? Okay, how do we find the inverse? So for the first one, you know that we said to find the inverse, you first have to say where there is f of x, you write y is equals to 3x minus 2. Then we make x the subject of the formula. How are we going to do that? That will be y plus 2 is equals to 3x. Then finally we're going to have, you divide both sides by 3, divide both sides by 3. So x is equals to y plus 2 over 3. So at this point now we said to write the final answer, okay, to write the final answer, you here where there is you need to put back the x over 3. So the final answer is going to be x 2 over 3. That is our answer here. Okay? Then the second one, g of f. So it means this is a composite function. So we need to make sure that in g here, g of f is equals to, in g is 4. Then here where there is x, we put what? F, which is 3x minus 2 close, then plus 1. So this is going to give us 12x minus 8 plus 1. Okay? Then this is going to give us 12x minus 7 when you simplify this. So here we're going to have 12x minus 7. All right. So again, we continue. In the same g of f, we put negative 2. We put what? Negative 2. So meaning here where we have where we have x here, we are going to slot in what? Negative 2. When we put negative 2 here, we'll say 12, where there is x, we put negative 2 minus 7. What does this give us? This gives us negative 24 minus 7, and that gives us negative 31. So this is going to be negative 31. That is what will be our answer here. Are we together? That is what is going to be our answer here. So we go to question 13. What is question 13 saying? Question 13 is giving us, question 13 is giving us, question 13 is giving us, it's coming from approximation, a grade 11 topic. Chiara estimated the length of a string as 15. If the true length of a string was the true length of 14.6, find the absolute error. So we are finding, the first one is absolute error. So absolute error is equals to recorded value minus true value. Okay, so we have an absolute error here. So that's what we are saying, absolute error. So definitely whatever we get inside here, whether negative or positive, it should come out as a positive. So the recorded value is what? Recorded value is 15 minus 14.6. What do we get? We are getting 0.4. So the first one here is 0.4. 0.4 is the first one. Then the second one, which is relative error. Relative error is equals to absolute error over true value. Is equals to absolute error over true value. So absolute error is 0.4. True value is what? 14.6. So we don't have a calculator here. We don't have a calculator. So we can just simplify this one. We multiply both of them by 10. This is going to be 4 over 146. Okay, when you multiply both of them by 10. So you can simplify this one by 2. Or we can simplify both by 4. I think 4 can go into 4 once, 4 into 14 twice, remainder 2 into 26. It can't go, isn't it? Into 26 it can't go. So meaning we need to go back to 2 and use 2 into 4, it's 2. Okay, then 2 into 14, it's 7. It's 7 and 3. So this one we can leave it here, 7, or you can divide it into decimal. When you convert it into decimal, you're going to get 0.027, but you can leave it at this point. You can leave it at this point, okay? You can leave it at this point. You still have the same thing, okay? You will still get the same answer. You will still get the same answer. You can leave it at this point than to force yourself to divide this, which may give you a very big number. I think we can say 2/73, okay? When you divide it, it will give you, but when you round it off, it will come to 0.027. But this one is okay for paper 1, considering the fact that you do not have a calculator. We move on to the next question. A point A is mapped onto A1 by translation. Find the translation, which is translation vector, isn't it? So the object plus the vector must give us the image. The object plus the vector must give us the image. Now in this case we have the object, so we need the vector. So it's the image minus the object. So the image is minus 3, 5, minus the object, which is 2. Oh, sorry, don't consider this. This is just supposed to. So when you simplify this one, what do you get? You're going to get minus 5. Then down here, you're going to get 1. Okay? Going to get 1. So this is what is going to be here. Minus 5, 1. All right? Then we come to the second one. Okay? We come to the second one. This one, we want to integrate. We want to integrate this one. How do we integrate? Okay. How do we integrate? I'm sure you know that we need to add a 1, then divide. So we are going to say here, integration of the first one, it will be, when we add a 1 here, we are remaining with -2. Then that -2, we need to divide it here also, isn't it? Then the second one, what are you getting? You add a 1 here. You're going to have minus 3x 5 over the 5 also, plus 5. Here we have an x which has got a power 0. So when you add a 1 there, it will be x plus this one. Okay? This is what is going to be our answer. But when writing the final answer, maybe on the first part, we can say 1 over 2. There's a negative there. X to the power -2 minus 3 over 5. X to the power 5 plus 5x plus c. Okay. So that is what we are supposed to get there. So we come to this one now. We come to this one. Okay. So the first thing, maybe even before we look at the question, we need to understand. We need to understand and even find, like, this is an isosceles triangle. So if this is 30, even this one is 30. So we know that these 3 triangles, 1, 2, 3, must add up to 180. So if we already have 60, then this is 120. Okay. So again, what about this one? 1, 2, 3, and this angle here, they should add up to what? 360, because this is a complete 10. So we have 160 plus 120 over, we add these 2, we have 2, 8, and 0. Then we subtract these 2 from a complete 10, which is 280. What do we get? 0. We get 1080. So this is 80 here. So now we can comfortably go to deal with which angles now that they want. So the first one is angle BAC. Angle BAC. BAC. Angle BAC, it's clearly seen there that it is what? 120 degrees. That is the angle there. Then the bearing of A from C. The bearing of A from C. The bearing of A from C. You need to put a note here. The bearing of A from C, it's this whole thing here, up to there. Okay? So meaning we have to, we know that when you have this case, maybe I must indicate here, when you have this case here, this angle and this one, I'm sure you know that they add up to 180. The same applies. This 160 here and this small angle here, which we do not need, should add up to 180. So if this is 160, then this smaller angle here is 120. I mean, it's 20 degrees. So to find this whole thing, we need just to subtract 360 minus 20 degrees. Where is this 20 coming from? It's this smaller angle here. From this concept, I think in our topics, well, when we are presenting this, I think we also emphasize this point. So this is going to be 340. 340, okay? So that is our 340 degrees. So we go to the other question here. Okay, so we have question 16, and the question says, the diagram below shows triangle ABC in which angle at B is 90 degrees. BC is produced to D. Given that tan A, which is this one, tan A is equals to what? 4 over. So I'm sure that you know that tan is equals to adjacent. Okay, I'm sure you understand that now we are dealing with what we call the soccer tower. Sure you know that now we're dealing with what we call the soccer tower, because this is the soccer tower. Okay, where the sine is the opposite over hypotenuse, cos is adjacent over hypotenuse. Okay, then tan is equals to opposite over adjacent. That is what that is. Okay, so that is what we need now to look at. So tan is equals to opposite over adjacent. So if this is the angle that we are given here, then the opposite in this case is this side. Okay, so this is where our 4 is going to be. The opposite to this one, we know that this is the hypotenuse here. So this is the opposite in this case. Then according to this angle here, this angle at A, this is the opposite. Then this one is our. Now, you know that when we apply Pythagoras theorem, this is going to be 5. Okay? This is going to be 5. What are we talking about? You know that when we say 4 squared plus 3 squared, this is going to give us 16 plus 9, which will be 25. The square root of 25 is 5. Okay? So now the question is that find cos. ACD. Okay, find cos ACD. So the first thing that we're supposed to do is we need to find this angle here. Okay? As in terms of cos, we need to find this angle here. So if we are finding this angle here, which is first of all, if we are finding cos ACB, remember we said cos is equals to what? here, adjacent over hypotenuse. Okay, remember that is what we said about that. I hope you remember that concept where we talked about that. All right, so that is now what we are looking at. So we are saying cos is equals to adjacent over hypotenuse. Adjacent over hypotenuse. Now, when we are considering this angle here, the adjacent is 4. The adjacent is 4 and the hypotenuse is 5. So that is this angle that is here. That is this angle that is here. Now, I hope you remember that the question, they're asking us to find this angle here. And if we can take you to the rules of quadrants, if we can put this one here. This cos, this angle is in the what? Is in the second quadrant. And in the second quadrant, cos is a negative. So we're going to say this angle that they're asking us, which is what? Cos ACD is going to be negative 4 over 5 because cos is a negative in the second quadrant. Okay, that is what we're going to have there. So then we go to question B. We go to question B. Okay, and look at what we are supposed to find there. Question B, what are we supposed to find? So we are saying calculate the radius of a semicircle. The radius of a semicircle whose area is, okay? Calculate the radius of a semicircle. So the first thing that we are supposed to know here is what is the area of the circle? What is formula do we use to find the area of a circle? The area of a circle. What formula do we use to find the area of a circle? This is the formula that we use to find the area of a circle. Okay? So now, since we are talking about a semicircle, it is half of this one. So we divide this by 2. Okay? So we are given that this is equals to 7. All right? Then what is the value of radius? So we're going to go on. This is equals to 2 multiplied by 7. Sometimes you avoid to multiply these two. Just leave, to get one value, just leave them like this. They help. So then we go on and say, what is this? This is 22 multiplied by what? This is 22 multiplied by, then we have our radius here. On this side we have what? We have 2 multiplied by, okay. So now, we need the value of the radius. That is what we want. So meaning we need to get the multiplicative inverse of this one here on both sides. 22 over 7, okay? 22 over 7. So now, that is going to give us radius is equals to, remember, this side, we're saying 22 over 7 here. 22 over 7. Okay? So, if we can look at, if we can look at simplification, 2 here, it will be 1. 2 into 22, it's 11. Okay? Then, this 11 into 77, what do you get? You are getting 7. So when you multiply 7 by 7, you're getting 40. You're getting 49. Then to get the radius, you need to square root this one, and you're going to get 7. Of course, usually you know that we get a positive and a negative number, but the radius can't be negative, so we're going to get 7 here. Going to get what? 7 centimeters. We're going to get 7 centimeters. So then we have this question on secant theorem. We've got this question on secant theorem. And me, what I like doing is that even before I read the questions, I want to make sure that I find the angles that I can easily find. Okay? The angles that I can easily find. So let me try and see. This is 70. This is also 70 here. Okay? This is also 70 here. And this angle here is 70. And this triangle is an isosceles triangle. So meaning this whole angle here is also supposed to be 70. So meaning this remaining part is 50. Okay? Is that clear? I'm sure that is clear. And you should also be able to know that if we treat this PTS R as a quadrilateral, a cyclic quadrilateral, this angle is going to be 110, because we said opposite angles in a cyclic quadrilateral add up to what? Add up to 180. Okay? So this is supposed to be that. That is very important. So if you look at what we've been given here, okay? If you look at what we've been given here, we can also find this angle here. If this is 70, this is 70, then what is this smaller angle? We need also to find this angle here. Meaning here we have 70 plus 70 is what? 140. So what is remaining is 140. So take note of that. Then, just in case, if this angle here is 50, then also this one here is 50. Because these are what? We call them angles in the same segment. Alright. So now, if we can still go further and find, we can go further and find which angle. I think this one, we have found this one. Then this is also known. Okay. So let's look at the other angle that we can easily find. Which one? Which other angle can we easily find? We have the parallel lines here, and I'm sure you understand also. I did mention when we were looking at bearings, you have got something like this. If this line is parallel to this one, then it means that this angle here and this one, they should also add up to 180. These are called allied angles. So we have parallel lines here. So meaning this angle and this whole angle here, what I'm saying is that angle TPR and angle PTS should add up to 180. So we can add all these here. What are we getting? Then we subtract from 180. This is going to give us one. When you add these two are giving us what? 90, isn't it? These two are giving us 90. Then 90 plus 90 plus 70, what are you getting? 90 plus 70, we're getting 160, isn't it? We're getting 160. So we have to make sure that we verify. You can verify the figures. Verify the figures so that you don't have a problem. So saying when you add these two, they'll give us 160. So meaning this angle here is 20. Okay, this angle here is 20. So that when we add this angle and that one, they give us what? So if this angle here is 20, then we can also easily find this other angle here. Okay, meaning you add this one to this. What are you going to get? You're going to get 130. So this one is going to be 50. Okay, so now we can go on and find what they are looking for. Angle RTQ. Angle RTQ. This one is 40. First one is 40 degrees. Then RST. RST, which we easily found. It's 110. And the last one is what? TRS. We have found it as what? 50. These are the angles that you need to find here. These are the angles that you need to find here. So let's go to this other question, question 18. So a woman has 500 company shares with a nominal value of 70 kwacha each, which she bought at 30 kwacha each. How much did she pay for the shares? So we are told that each share is 30 kwacha, and how many shares were bought? 500. So you need to multiply this one. When you multiply this to 500 multiplied by 30 kwacha, what are you going to get? Okay, what are you going to get? This is going to give us 15,000 kwacha. It's going to give us 15,000 kwacha. Okay, so we can go to the next question. We'll go to the next question and see. So we go to the other part. P is a point 3,1 and Q is another point such that the gradient of the line PQ is -1/2. Write down there. So the gradient is already given here. The gradient is already given of these two points. So the only thing that we're supposed to do here is to write the equation. And you know that when we are writing the equation, we use, usually I use this formula. Okay. So these points that were given 3,1, this is going to be our x1, this is going to be our y1. So we replace y minus 1 is equals to, what is our gradient? M is the gradient here, which is -1/2. That's what we've been given. Okay. Then open brackets, what do we have as x? It's -3. You close brackets. Then we expand this. In most cases, I like to cross multiply here, where 2 is going to multiply this side by 2y minus 2. This is going to be -x. It means this side I remained with what? -x. So like I just have -x. So it will be, I remained with -1. So I'm distributing -1 now. So I'm going to have -1 plus 3. Okay, so at this point, it's the question of you rearranging so that you put it in a standard form. So you're going to have 2y plus x is equals to 3 plus 2 when the 2 comes this side. So the equation will be 2y plus x is equals to 5. That's what is going to be the equation. So we can write the equation here. The equation is 2y plus x is equals to 5. That's the equation that we're going to have. So we can go to another question. Here's the question that we have. Okay, here is the question that we have. So in the space below, in this answer space below is an incomplete pseudocode for a program for calculating the curved surface area of a cone. Complete the curved surface. Complete the pseudocode. Complete the pseudocode by filling in the blank spaces. So the first thing that you're supposed to know is to write what formula do we use to write the area, to calculate the area of a circle. This is the formula that we use to calculate the area of a circle. You need to know this. But I'm sure you always know that pi is always there in the computer system. So what we're going to enter here, we'll enter R and L. Okay? We'll enter R and L on entering part here. Then now, surface area, curved surface area, which is this part, is equals to what? We can bring pi multiplied by R multiplied by L. That is how it is done. And I think we have completed that part. All right? It is as simple as that. That's not a problem there. So then we come to question B. we look at the diagram below is a right triangular pyramid. Is a right triangular pyramid ABCD, with AB being equal to BC and equal to AC. These points, the base is equal. So the order of rotational symmetry. So this can be rotated 3 times and it will have the same position. So it will look like it hasn't been rotated in 3 rotations. Okay? So the answer here, what is the order of rotational symmetry of the pyramid about OD, which is this one? So the answer is 3. Get question 20. Question 20 was saying, read the question. It is given that y varies directly as the cube root. Y varies directly, k directly as the cube root of x, and inversely as the square of z, I need to write this. Then, okay, so we need to find the value of k here. Y is equals to what? Y is equals to 2 here. Then k, we don't know it, that's what we are looking for. 8 over the square of what? The square of z. So 4 squared. So what are we supposed to do? 2 is equals to the cube root of 8 is 2. So we have 2k over 16. Here we have what? 16. So we have 16. Are we together? So we can go on and simplify this. 2 is equals to 1k over 8, if you like. 2 here, it's 1. 2 here, it's 8. So this is the same as k over 8. So to find the value of k, you say 2 multiplied by 8, which is going to give us 16. So this is what we're going to get as the value of k. So we're being asked to find the value k, which is the constant of the variation. So here we are saying our k is equals to 16. All right? Then find the equation connecting x, y, and e. So this equation is what we are going to write as now. Y is equals to, since now we know what k is, you put this one. Then the cube root of what? X over z squared. Okay? That is what we are going to write here. The equation is y is equals to 16. Then we write the cube root of x over z squared. That is what we are going to have. Okay? Then now let's find the value of what? We want to find the value of z when y is equals to, we want to find the value of z when y is equals to 12 and x is equals to 27. So we need to make like z the subject of the formula. So when we make z the subject of the formula, z squared and y will switch positions. So we're going to have like z squared is equals to k multiplied by cubed over y. So we know now that our k is 16. Then we want what? The cube root of, we want the cube root of 27 over y, which is what? 12. Are we together? Y, which is 12. So we continue now. So this is going to give us 16, then multiplied by, what is the cube root here? The cube root is 3 over 12. Are we together? So at this point we have z squared here, don't forget. 3 here it's 1, 3 here it's 4. So we have z squared is equals to 16 over 4. And 4 here, it's 4. So z squared is equals to 4. And z is equals to the square root of 4. And you know that a square root always produces two values, a negative and a positive. So here we have z is equals to what? Positive 2 or negative 2. Positive or negative 2 here. That's what we are getting. So we got question 21. So question 21, we want to write the inequalities that represent inequalities that define the unshaded region R. So we start with this one. I'm sure you're able to see that this is undotted. I mean, this is a dotted line. This one, it's a dotted line. So it's the simplest equation or inequality that we can write. So we're going to say it cuts the x-axis. It cuts the x-axis. So we're going to say x, and then what we have? 3. We want this region where R is, isn't it? So we say less. Less because the line is dotted. That's what we're going to get. As for the other two, we need to make sure that we get the coordinates. So for instance, this same one, I can start with, we need to get 2 points on these lines. So for instance, I'm dealing with this one now. So I'm going to get these two coordinates, 0, 3, which is this one here. And then also this one here, which is what? 3, 0. So now, after that, I need to find the gradient. And I'm sure you know that the gradient, which is m, is equals to y2, which is 0, minus y1, which is 3, over x2, which is 3, minus x1, which is 0. So this is going to give us negative 3 over 3, which will give us negative 1. So that is what we're going to get. Now to write the inequality or the equation, first of all, we are going to say y minus y1, which we did, is equals to mx minus x1. So here we can pick any of these two coordinates points here. If we're getting this point, this will be our x coordinate, this will be y. We're getting this point, that is will be x coordinate and y coordinate. So we can pick this one. We can use these coordinates. Our y1 there is 0. Then what is our x coordinate? Our x coordinate, so here our gradient first of all is negative 1. Then x minus, what do we have? 3. So this is going to give us y is equals to, because here we'll get a 0, minus x plus 3. Okay? So if you want, we can rewrite this one. Remember that here we have, so at this point now you can rewrite this if you want into this. This is equals to what? 3. Now in this case we want this region that is on top here. So the region that is upper this line, on top of this line, it's greater. Okay, it's greater. So we are going to say, in terms of an inequality, this is y plus x is greater or equal to 3. So y plus x is greater or equal to 3. That's what we're going to have. So we do the same thing even for the other one. We do the same thing even for the other one. So we get the same points. The first point here, it's going to be what? The first point will be 0, 3. Then now I come and get this point here, which is 6, 0. So I do the same process of finding my gradient, which is 0 minus 3 over 6 minus 0. Am I right? That's what we're going to get. So here, 0 minus 3, then 6 minus, this gives me negative 3 over 6, and this will be negative 1 over 2. So that is our gradient. Our gradient is that. Then we come to the equation, y minus y1. So y1, I choose to get the 0 here. Okay, I choose to get a 0 there. Then equals to gradient. What is our gradient? Negative 1 over 2, open brackets, we have x minus x, which is 6. Okay, so we say at this point we can say y is equals to negative 1 over 2. Okay, x minus 6. I've told you that when the gradient is a fraction, it's better to simplify by saying you cross multiply this. So 2 must come this side. 2y is equals to minus 1 x minus 6. Okay, then you proceed and say 2y is equals to negative x plus 6. So you can write this one by saying 2y plus x is equals to 6. Now when we are dealing with the inequality, when you come look at the shaded region, the wanted region is this part that is not shaded, okay, which is below the line. So down here it is less. So we're going to say 2y plus x is less than or equal to 6. So 2y plus x is less than or equal to 6. Okay, so basically this is what we are supposed to do. So this takes us to the second last question. And so we are saying, how do we solve this one? How do we solve this equation? So that equation, we are going to say, I will rewrite it first by saying 5x squared minus x is equals to 0. Sorry, I did not need to put the brackets, please. I did not, or let me rewrite it to, okay, just like that. I did not need to put the brackets. Okay, so without the brackets, now the second point is where we need to factorize what is common, and that is x. So here will remain with it. Then this is equals minus 1 is equals to 0. Are we together? That is what we are supposed to do here. So now at this point we say, how do we find the values of x? The first one, we say x is equals to 0, or 5x minus 1 is equals to 0. So we have x is equals to 0, or here you're going to have 5x is equals to 0 plus 1. So this will be 5x is equals to 1. So x will be equals to 1 over 5. So the first one here, okay, for the first one we have two values of x. So x is equals to 0 or 1 over 5. Those are the values of x. So then we go on to this one. Find the coordinates of A. So what are we supposed to do? So we need just to, we know that here, how do we solve this one? We know that at the point here, the y coordinate is 0. The y coordinate is 0. So we just have to equate this whole thing to 0, which will be negative x squared, isn't it? Plus 2 plus 3. Okay, so this must be equated to 0. So we solve now this one. Let's see if we can use factorization method. This is this one. Then we have 2. So we can use what? Okay, yeah, we can use these factors. So we're going to say negative x squared minus 2x. Okay, is it going to work? Is this going to work? No. When we add them, okay, it's supposed to be, sorry, it's supposed to be these two. Okay, it can't work like that. So it's supposed to be, yeah, these two. So this is supposed to be 3x. Okay, then minus x here, okay, and plus 3. Are we together? So that is what we are doing. So we need to factorize now here what is common. We need to factorize here what is common, which is going to be x. Then here we remain with minus x plus 3. Okay. Then here we're going to have plus 1 and x plus 3. Okay. So now this is going to be x plus 1 is equals to negative, or I can write 3 minus x. It's the same. This is supposed to be a minus here. Take note. This one, it is the same as negative x plus 3. These, they are the same. So at this point, don't forget we have a 0 here. We have a 0. So at this point now we need to equate all these to what? To this one, to 0. So we're going to say the first one, this is equals to 0. The second one, this will be like negative x plus 3 is equals to 0. So this is going to be x is equals to 0 minus 1. 0 minus 1, which will be negative 1. 0 minus 1, it's negative 1. And this one is going to be negative x. Then 0 minus 3, it's negative 3. So you divide by negative by negative. So we're going to have x is equals to 3. So x is going to have two values. The negative one and the positive one. So if we go back to the question, they want the coordinates of what? A. A is on the negative side. So this value which we found as a negative, okay, that is the coordinate, x coordinate of A, and the y coordinate is 0. So the coordinates of A here, it's what? Negative 1, 0. Then the maximum, find the maximum what? Find the maximum maximum value. Find the maximum value of the graph. Okay, so what are we supposed to do here? So maybe we can first find the x. Okay, we can first find this one and see what we're going to get. Okay, so here what we're going to get is that b is a negative. When you bring the negative way, to be negative 2 over 2 multiplied by a, which is negative 1, the coefficient here, negative 1. So this is also going to be like this. Okay, this is going to be like that. So what are we going to get here? What are we going to get? The x coordinate is going to be the x coordinate is going to give us the x coordinate here, the x coordinate is going to be 1. So to find the y coordinate, which is the maximum or minimum value, in this case the maximum value, now we replace where there is x here, we put 1. So we're going to start with y is equals to negative 1 squared plus 2, 1 plus 3. So this is going to give us negative 1 here plus 2 plus 3. When you work out this one, it will give you 4. So the y coordinate here, so this is going to be 4, which is y. Y is equals to that. Then we look at the last question. We've come to the end of this paper. Okay, we've come to the end of this paper. So the diagram below is a graph of a moving object which decelerates. Okay, so take note that we always say acceleration is equals to final velocity minus the initial velocity over time. Okay, so deceleration, we can say it's like the initial minus the final velocity over time. Okay, that's deceleration, which is like the opposite in this case. So although the object decelerates uniformly, okay, at t, so that is 8 meters per second square from a speed of, okay, so the speed there, which is the initial up to v. So v is the final here. Okay, so now deceleration has been given here. Deceleration has been given as what? 8. Okay, deceleration has been given as 8, which is equals to the initial velocity is this, then minus v, which is the final velocity, over time. What is the time? Time is 6. Okay, that is what. So we want to find the value of what? Of v. So let's multiply this to, what do you get? What do we get when we multiply these two? What are we going to get? 6. This is going to give us 48. This is equals to 52 minus v. So we want to find the value of v. Okay, so when we bring v this side, when we bring v the other side, it will be positive. Is equals to 52 minus, this one comes the other side, 48. So v is equals to what? 4. That is what we're going to write here, 4. Okay, that is what our v is going to be. Then total distance traveled for the whole journey. Total distance traveled for the whole journey. I'm sure you know that this one, what we always do is we find what? The area under the graph. So the area under the graph, that's what we do, isn't it? So we can find the area of this part. So we find the area of, I don't know, we can divide these things in 2 parts. For me, I have chosen to say, okay, let's treat them. We find the area of this part, as well as the area of this other part here. This other part here. Okay, this is how it is, isn't it? So the area of the first one, which is a parallelogram, the whole distance from this point up to this one, which is, it's 16. Then from this point up to this one, it's what? It's 20. Then from here, it is what? 4. Then for the triangle here, let me bring it this side now. For the triangle, what do we have? The base here from this point up to this one, it's 6. Now take note, I'm looking at the triangle from this point up to that point. So meaning I need to remove this 4 here. So I'll remain from this point up to that one, I'll remain with 48. Okay, I'll remain with 48. So we are finding the area of this part and the area of this one. So like this is a trapezium and this is a triangle. So the area of a trapezium is 1/2 a plus b then h plus 1/bh. This is for the, what's this? For the triangle. So 1/2, the opposite sides here we've got 16 and 20 over 4. I mean multiplied by 4, which is the height, plus 1/2 multiplied by the base, which is 6, multiplied by 48, which is height. So here we add what is in the brackets. What do we get? We get 36. And this 36, this 4 can be divided by 2. What are we going to get? We're going to get 2. Plus, also this 2 can go into, this 2 can go into 6. How many times? 3 times. Okay? So 3 multiplied by 48. So what do we get? We can try to multiply. This is going to give us 144. This is going to give us 72. So when we add these two, what are we getting? what are we getting? We're going to get 216. So the distance traveled here is going to be 216. 216, the distance traveled, that is 216. Then average speed for the whole journey. The average speed for the whole journey, what are we going to find here now? The average speed for the whole journey. Okay, so average speed is always, speed is equals to distance over time, isn't it? Speed is equals to distance. Speed is equals to distance over time. Our distance is 2 over time, which is 20. Okay, so you have to divide this one here. What do you get? You can either leave it in a fraction form, or you can leave it as a decimal. You can leave it as a decimal. Okay, so if we are converting it, we're writing it as a decimal, it will be 10.8. okay, it could be 10.8, or you can simplify this one. 2 here, it's 10. 2 into 2 is 1. Then 0.8. Okay, and then further here it could be divided. This one can divide this one again by 2 here, it's 5. 2 here, it's 5, 4. So at this point now we can say, you see, this one 5 here, it's what? It's 1. Then into 4, it can't go. So it's like we have this one. Then point, you add a 0 to this one, what do you get? So it could be, even you can say it goes into here 10 times the remainder, 4 over 5. Even this one is acceptable. So it could be 10, 4 over 5. Okay, that is your average speed. I hope you have followed everything and you've managed to get the concept. This is the paper that we were solving. Okay, this is the paper that we were solving. Thank you so much for watching. Now we have come to the end of this paper. Please don't forget to subscribe to our channel, as we are going to solve many more papers. Thank you.